Good morning, JupyterCon, or good evening, depending on where you are in the world. It's a great pleasure for me to introduce Min Ragan-Kelley. Min is one of the earliest contributors to the project, as he has been working on Jupyter or IPython for over 15 years. We owe him some of the main components as he started on the JupyterHub project and was one of the main architects to the classic notebook. Today, Min is the head of the Department of Numerical Analysis and Scientific Computing at the Similar Research Laboratory and works full-time on Jupyter. Everyone, please welcome our second keynote, Min.
Thanks very much. Thanks, Sylvain and Lorena, for having me. Welcome to JupyterCon. I hope everybody's having a good conference. Get started presenting. All right. So today, I'm going to be talking about scope and how Jupyter came to be out of the little IPython project, and how, in general, open source projects can expand in scope and when that makes sense, and when there can be challenges associated with that, and some of what that means. So a bit of background about that. So what do you mean when we say scope like this? So a few years ago, you have these, when you maintain a project, often can be quite challenging, that people want you to do things that you don't feel are appropriate or manageable, and you can get a little frustrated, like I was in 2014. So we're going to get a little bit of a view of IPython scope over time, and how it became Jupyter, and all the things that we do that let us have the conference that we have today. So in 2001, 19 years ago this month, Fernando created the first 0.0.1 version of IPython. It was 110 lines of code. The whole file, that's counting only significant lines, so the whole file is 200 and some. It was one file. You can download it from archive.ipython.org. It doesn't actually work on its own because it has dependencies and things. But a few weeks later, in November, Fernando created IPython 0.1, the first real release of IPython. And here's a screenshot of a session that I managed to get working last week, running actual IPython 0.1. You can see a few contributors, and it has the basic functionality that we're familiar with: auto call, adding parentheses, and magics. Back then, magics actually started with an @ symbol, because we didn't have decorators yet in the Python world. Python's been around a pretty long time. We jump forward 10 years to December 2011, and we have the first release of the notebook. So this is the IPython notebook that would eventually become kind of the foundation of what's Jupyter today. So we went from one file up to 46,000 lines of Python code and 3,000 lines of JavaScript code for the interface. And jump forward today, in 2020, we have IPython is tens of thousands of lines of code. The notebook is a separate project that's about half and half Python and JavaScript. We have the JupyterHub project that's as big as the notebook itself. And we have Jupyter Lab, our largest project, that on its own is 100,000 lines of TypeScript code. And all together, across the 9 GitHub organizations that compose most of Jupyter code on GitHub, there are 282 repositories of things. So this is a bit of a story about how we got to this wonderful Jupyter Lab interface that can do all these amazing things. How did we get there from one file that gave us, a nicer terminal experience? How did we get from one file to 282 repos? And it's possible that 282 has changed in the last few days. It changes a lot. So a bit of fun with some data. So while I was working on this talk, I did some looking at what kind of information can I get about Jupyter over time, and I collected some data that about contributions. So there's a cool project called the GitHub Archive dataset that collects all kinds of events of interactions with GitHub repositories. So there's our creating issues, making comments on issues, opening pull requests, pushing changes, all these things. That information only goes back so far. And I also collected information about posts on the IPython dev mailing list and the Jupyter Google group, and also commits on IPython before we were on GitHub. So collecting information from our Subversion repository. So I have information back to 2003, not all the way back to 2001, but the numbers were pretty small back then. So I think this is a good illustration of how activity has kind of grown over time. And a lot of what's represented here are people making comments, so people saying, whether that's talking through issues or reporting bugs or what have you. It's a large fraction of what's going on any given day in any Jupyter project. Looking at number of contributions per year across all these GitHub organizations, we can see that today we get around 70,000 contributions in a given year. That corresponds to close to 200 events a day, whereas 10 years ago it was closer to 5 events a day. Right? It used to be a lot easier to stay on top of everything going on in the world of IPython. As things grew over time, that's no longer something one person can do. So some key points in history is we see an immediate take up when IPython arrives on GitHub, whether that was because of GitHub or because of the same reasons we moved to GitHub. There was more activity in the project. You can see the first release of the notebook, and then everything bifurcates when we split IPython into all the different components of Jupyter. And then activity on IPython itself goes down, but activity on the project as a whole continues to rise. And it's kind of stabilized over the last few years with lots of activity on Jupyter and JupyterHub and Jupyter Lab being the most active areas. So if instead we view that as, rather than just the counting events, but also the number of people engaged with the project, we see the number of people participating in the project is similarly going up quite rapidly. And that's actually continuing to rise. So the total activity has stabilized, but the number of unique people who participate per year continues to rise. So that's with the way this data is computed, the cumulative sum is a bit overcalculated because there's some duplicate counts, but that's totaling around 7,000 people who come and interact with Jupyter on GitHub or on mailing lists and things in any given year. So that's quite a few people, and that's part of why we have a conference dedicated to this topic, is that there are quite a few people who have a reason to interact with the project. And we saw that number of 282 repos, but if you look at any given month, we actually only have on the order of 100 repositories that have activity on any given day, or I'm sorry, on any given month. But still, 100 repos to watch is a lot more than any one person can do. So if one file made by one person, it doesn't exactly scale to 100 active repositories. So back to this topic of scope. So what do I mean when I say scope for a project? So when we're working on software, a tool like IPython, generally you have some problem that you want to solve, right? So Fernando was solving a particular problem that he had as a graduate student in Boulder with IPython. And pretty much as soon as you have something useful, it's almost useful for a problem that's nearby, right? You solve one problem, you're immediately presented with, oh, if only I made this this little change, added this little feature, then it would be so much more useful. But when thinking about that, we always have to think about what can we support and more importantly, maintain when we're thinking about new features and things to add for any given project. And importantly, to keep in mind that new features always have a cost, right? When you implement new features, you have to deal with testing. Presumably, you implemented, we're implementing features because somebody wants to use them. And that generally comes with some amount of support, right? You make something you want people to use. If they're going to use it, they're probably going to have questions about how to use it. Maybe it doesn't work how they expect it to. Maybe they're finding bugs, that kind of thing. And also more features. There's more, there's more code to interact with each other, and that adds what I like to think of as inertia to a project, right? So when sometimes you find that a piece of your software or a new problem that you want to solve involves changing something that already exists. Well, the more things that already exist that are using those APIs or whatever, the more work it is to make any given change, right? Because if you have to update everything that used that code, then it's more work to make any given change. People actually using your software also adds inertia, right? You don't want to break things that people are actually using. That's frustrating. But at the same time, sometimes you can't get where you want to go without causing some kind of breakage. So that's the kind of trade-off that we always have to think about. So as maintainers of community software, we have to allocate our time, right? There are a lot of activities involved in maintaining a community project. We have to field support requests. So when people have questions or proposals, we have to spend our time, thinking about those things and responding to them. We have to find and fix bugs, whether we found them or others have found them and reported them. And then we need to work on, reproduction test cases, figuring out where the bug is. When we're lucky, we're excited about solving new problems, and we can add new features to our software. But in community software projects, the maintainers aren't the only people writing new features. We also have to say, somebody says, I've already written this new feature for you. Here, you may have it. And that's wonderful and generous, but it can also be a lot of work to say, yeah, that's great. We'd love to have this change. But, can you make this change and that change? And code review is a really huge amount of the work for an active community project, because you're getting contributions from all over. And it takes a lot of work to manage bringing those in. And we also have to do documentation, because presumably if you want people to use your software, you should explain how it works. And finally, we might have to do our jobs, right? A lot of people who maintain this software do it in their spare time, right? I've been one of the supremely fortunate people who gets to do a lot of this work as my job. But when it's your job, you still have, the job part of it is generally, you're not just paid to do whatever you want. You have some priorities, whether they're specified by a grant or by the management structure where you work. You don't always just get to do whatever you want. You may have a lot of time allocated to the project, but that the people paying for that time often get to say, how you prioritize that time. So taking all this together about what's the scope of a project, what kind of problems are we trying to solve, for IPython, in the context that we were in 2001, in the context of computational research. So what's that process look like, right? At a very simple level, you may write some code, maybe some analysis, a model, simulation. You run it, it produces some kind of output. You make some figures to illustrate and communicate that. You write it up in a paper, and you share it, right? So you share it, reproduce other people's results, and that's the scientific process, right? But in reality, it's a much more iterative process, right? You write the code, you run it, and immediately immediately fails. So you have to go back and figure out why that happened. Then you write it, you get some results, but as soon as you start visualizing them, you see, like, wait, these results don't make sense. Clearly, there was something more subtle wrong in the code, and then eventually you're happy with it, and you get to the paper writing process, and then the reviewer says, well, that's all well and good, but can you please rerun it with my data set that I published last year? And then you finally get to the sharing and reproduction state, and then you might still you can have errors and things that get past review, and people find them, and so it's always an iterative process. And IPython was focused very specifically on solving this one piece of the iteration loop of saying, I'm writing some code. This is a research project. I don't necessarily know what code I want to write. I do some interactive executions, do some tweaking, some fiddling, and go back through that iteration loop to say, figuring out what code you want to write. Try to make that more efficient, more pleasant. So how does the scope of a project like IPython grow? Right, in 2001, Fernando has the first public release of IPython 0.1, and it's already got a new feature. Right, it already has this new feature where putting question mark to inspect an object can. It used to only work at the beginning of a line, but maybe Fernando explains that he's often tab completing a name and then the cursor's at the end. So wouldn't it be nice if I could also type the cursor, the question mark at the end of the line? And so that feature is added. Then 2002, we see that IPython now works on Windows. Maybe there were some Unix assumptions in the early versions. And then 2004, a lot of what people were using IPython for was interactive visualization, whether it's with GNU-plot or Matplotlib. A lot of the work in IPython, we have these tools like Matplotlib or others that have nice interactive visualizations that use GUI toolkits, but those GUI toolkits have event loops, and keeping the interactive terminal interactive while that event loop was running was a challenge. So there were some things involving threads and cooperating with event loops. That was a lot of the work going on in IPython in the early days. So it's all about, I have something useful, but I still have, there's always a new problem to solve. There's always a new challenge, a new feature that I want to make not just this activity useful, interactive, I want to make that activity interactive. And then, maintenance tasks. Python 2.4 comes along and says that now the @ symbol means a decorator, so IPython needs to change its magic syntax to the % that we know today. And we have this interactive environment for poking around. Maybe you're using that for demos or teaching. IPython developed a demo module for maybe you want to do you want it to look like you're doing a live demo, but you don't want to be stressed about typos while you're typing in front of a crowd. The demo module allowed you to kind of record and play interactive sessions to get kind of a balance of interactivity and pre-recorded behavior. And then, we're always finding new things that could be more convenient in an interactive context, right? Python has this wonderful time it package, but it takes a bit of thinking and typing to get to your first timing measurement. And this is the perfect kind of thing for IPython, where we can make an activity more convenient, more efficient when we're thinking about an interactive context. So all these are in the context of terminal IPython, making interactive terminal computation more pleasant, more efficient. But one of the things that's lacking is persistence, and also dealing well with larger bits of code. Then we're in 2005, Google Summer of Code project to build a notebook document format for IPython. This is with Fernando and Robert Kern as mentors with some Google Summer of Code students. And the idea behind this came to a prototype of an XML-based document. So we have the concept of some text and a sequence of cells with have input and output. So these should be familiar concepts to those of us in the future that gave us Jupyter. And these documents could be converted to HTML files, restructured text. They use IPython for execution. There was a WX-based prototype UI for creating these documents. At the same time, we have the Chainsaw project. So this is taking, when you're thinking about IPython as a tool for interactive computing, and you're thinking about, okay, what if we want to extend this to something like a notebook? We get this separation of all these tools, magics and interactive shell objects and all these things for making nice interactivity, cooperating with event loops, all this stuff. But when we start thinking about multiple interfaces, we might want to, Fernando and Brian Granger started thinking about, okay, how do we separate these components so that we can reuse as much of IPython as we can, and think about multiple interfaces so that those interfaces that can share as much as possible. So this re-architecture of IPython started around in 2005 and developed the first IPython protocol, right? So if you're familiar with Jupyter, a lot of what we do in Jupyter is work on protocols. So the first IPython protocol looked a bit unfamiliar to the message spec we have today, but the concept was really the same. Of we have taken the interface and the execution kernel of an interactive session and separated them, and they communicate with the protocol. So we're describing this read, eval, print loop model using network commands, network protocol. And a fun note from that IPython protocol document from 15 years ago is that one of the challenges and unsolved problems was, what do you do if a background thread produces standard out? And that is still an issue that we're dealing with in the Jupyter protocol today. We have a solution for it, but there's more than one right answer, and it's actually kind of a hard problem to solve in a robust way. So the following summer in 2006, I get to make my first commit to IPython as a summer student, as an undergraduate at Santa Clara, working with Brian. My first commit was, this is learning subversion, so when we add commits, they just kind of stay there. So this is my first contribution to IPython or open source stuff in general, or I think subversion in general. And it was, of course, adding some trailing space, which I know people who have been collaborating with IPython for a long time have been frustrated by, so I apologize for that. So this summer, I was working with Brian and Fernando on what we called the IPython kernel, which is the first where we got the second implementation and the first really complete implementation of this protocol for execution. And by this point, we were implementing it with an RPC style, or remote procedures call style interface from Twisted called Perspective Broker. And what we ended up with at the end of the summer was a tool for interactive parallel computing, right? Because this is from the concept of, once you have a protocol for remote execution, if you've got an API for running code over there, then it's not that much to add. Don't just run it over there, run it in 5 places at once, 10 places at once, 100 places at once. And so that's actually the architecture behind, the underlying technology has changed, but that's the architecture behind IPython Parallel today. But because we built this protocol for remote execution, we also applied the same protocol to build a different kind of application, IPython Notebook. Right, so this is about 600 lines of Python and 600 lines of web code, HTML and JavaScript and stuff. get the first to get this prototype IPython notebook, right? You can execute code, you get output. There's some familiar concepts here. This was an early prototype. It didn't actually have the concept of documents or saving or anything, just the UI principles of saying, can we take this protocol and expose it to the web? But because it was built on the same tooling as this parallel computing framework, this version of the notebook, you could type, depending on how you launch the notebook server, every time you execute code, it might actually be doing it in parallel on any number of remote processes. So a year later, I'm finishing my undergraduate thesis at Santa Clara, talking about interactive computing with interactive parallel computing with IPython and the notebook ideas. And at this point, we have the next version of the notebook with, this looks perhaps even more unfamiliar than the last one. And I'll just highlight a few aspects of it. So you have the concept of sections and nodes. So every, we still have the concept of text cells and code cells that we called IO cells. But everything is a node in a graph. And you can have arbitrarily nested sections. Everything has tags, has comments. We have our familiar input and output for a code cell. It only supports text. And everything has a modified date and a created date. So there's a lot of metadata attached to everything. And importantly, because all this was actually stored in an SQLite database, your notebooks weren't files. Your notebooks were queries on a database. And the database actually had the notion of users and owners and permissions, and you could search for things. It was a bit different than what we have today. So highlighting some quotes from my thesis that I dug out. So part of the reasoning behind this database model is that being able to do things like search for any time you used a function or any cells created during some window. So you can say, like, find me the cells that I created on last Thursday or everything I did in October using database queries on this metadata. And then this bit from the conclusion that completing the notebook interface will be a major step forward in making IPython a powerful scientific environment. So the notebook didn't end up being what we were working on at that point, but I think the idea behind it was, I think we were slowly but surely making our way towards something that I think people have found useful. I'll also note that year before this, in 2006, William Stein and the SAGE project, they shipped a web-based notebook, and people were using it. It was awesome. People loved it, and it was a wonderful illustration of shipping things that people want to use and love right away. And it took us on the IPython side an awful lot longer to get something actually shipped. So now, 2008, we released IPython 0.9. This is actually the first release of the protocol. So we were working on it from 2005, but it didn't make it into a release until 2008. And the notebook also didn't make the release, right? We released the parallel computing design and kind of the re-architecture of IPython to enable these protocols, but the notebook didn't make it. But now we're up to 33,000 lines of Python code in the project, right? So we're an order of magnitude bigger than the first release of IPython. So what does that look like in terms of activity? You can see there's, over time, the contributions are stepping up a little bit, right? Still in the on the order of the peaks are around 10 contributions in a day, right? This is something someone can stay on top of for an active project. It's growing. And the number of unique people interacting with the project is also steadily growing, right? Now we're getting 10, 20, 25 people interacting in any given month. So that brings us to 2011. At this point, we've redesigned the protocol. So So the ideas of the protocol are the same, but it's been implemented using a new technology stack called Zero-to-Q for various reasons, partly to do with easier support for Python 3. And this is when we get our first new interface on the same protocol. So this protocol first used for parallel computing is now expanded to a terminal type console interface called the Qt console. And we have this protocol for remote execution. And because we're doing this over the network, we're not confined to terminals, we can also get rich output and display. So we can have figures right in line. We don't need to open windows. We can get figures in the document. And then just a few months later, in December of 2011, we have the first release of the notebook. Now we're up to 46,000 lines of Python, 3,000 lines of JavaScript for the user interface. So we're stepping up. But now we've got 3 applications built on the same protocol. We have parallel computing, we have the console, and we have the notebook. And this is the foundation of the notebooks that we have today in Jupyter, right? They're JSON documents. There are a list of cells. There's code cells, markdown cells. There's some things inherited from the early design. So you had heading cells, which kind of came from our concept of sections that we were thinking about. And this, UI is from 9 years ago. It's not as shiny as what we have now. But this is really the tech from the technological foundation of what we're using today. So what's missing, right? So we finally shipped a notebook that we've been working on for a long time. What's missing? Now we have notebook documents, but we still wanted that idea of taking those notebook documents and integrating them into documentation, publications, and so IPython 1.0, another couple of years later, we have NB-convert is added to IPython. So now we're up to 60,000 lines of Python, 6,000 lines of JavaScript. And now we can take notebooks, not just build them interactively, but also convert them to HTML, to restructured text, to LaTeX, and other formats, and integrate them into publications, pipelines, blogs. So now what's the missing piece, right? We have this interactive notebook. Well, there are ways it could be, the interactivity could be even better, right? And then IPython 2.0, another year, now we've got interactive widgets, right? This involved additions to the protocol and a lot of work on both the Python and JavaScript side. And now we have outputs that can be interactive, that can put controls on the page. And when you interact with those controls, new code executes on the kernel, and new output is produced. And then, so what's the next stage? So now we got notebooks, we got nice interactivity. We can take the documents and convert them to all kinds of things. What's next? Well, we were interacting with the Julia community a lot at this time, because with this protocol and the way it's put together, there's nothing really Python specific about it. And the Julia community was pretty excited about being able to reuse a lot of the work that we'd done by implementing the kernel side of the protocol, so that Julia community could use notebooks without having to write the notebook in Julia and all these things. So we did a lot of work on the protocol and on specifications and things to take a lot of IPython and Python assumptions out of the notebook. This is still a single repo, IPython. But now IPython is fundamentally a multi-language, language agnostic protocol. And now we're up closer to 100,000 lines of code in the repo. That's 3/4 Python and 1/4 JavaScript. That includes tests and things, not just the application code. So now we have something called IPython that isn't specific to Python. It has notebook, it has documents, it has interactive clients in various forms, it has interactive parallel computing tools, it has web applications. And it's all just one IPython. So how has our activity grown? So now we can see with the release of the notebook that it's really starting to pick up in terms of the amount of activity. So we've gone from 5 or 10 interactions a day to closer to 100. And you can see these periodic spikes of kind of flurries of activity tends to be around SciPy in the summer, because throughout all this time, there were very few people who had the opportunity to, to get paid to work on this. It was a lot of volunteers, students, and the main time that a lot of us could actually do this work was when we got to go to SciPy and maybe pretend that we didn't actually have our jobs back home and we could focus on doing fun work with our friends. So then the next release, so this is the time that IPython's gotten really big, and we've had this idea to kind of spin things off into Jupyter. The next release of IPython is the first one to get smaller. Now we're back down to the size it was years earlier. IPython 4 is 30,000 lines of Python. There's no JavaScript anymore. It's back to just the terminal. And all those other components are spun off into their own projects under the Jupyter name. And we can see how, take some kind of highlights of that split. The reason it wasn't just split in two is there were different aspects of this work that each component had its own level of maturity, right? These pieces were arriving years apart. So, widgets at this point were brand new, but the notebook format had been around for years. And you can see this reflected in the activity, that when this splits, there's still a lot of activity in the notebook repo, and then a huge explosion of activity when JupyterLab project starts up as the new UI code. Widgets is still very active, but the notebook format repo gets very little activity, right? Because there's a lot of inertia in the format specification. So the different pieces had different levels of maturity and different levels of the scope for each project. They each had their own scope, right? Not just Jupyter as a collection of humans, but each piece of software has its own scope. And so at this point, before the split, it was hard for anyone to follow all of the activity on Python. I tried, but it was really hard. And then when we split it across the Jupyter stuff, it became even harder and basically impossible. But the important thing was that with the scope of all these projects and the humans involved being able to be different, that nobody should have to know and watch everything going on across Jupyter, right? There's so much going on that nobody should actually be able to, nobody should have to see everything. And that's good because nobody can. There's so much. So back to the scope of IPython, right? IPython was solving this one problem. But after keep having these adjacent problems to solve, Jupyter now has pieces of all of this are in scope for Jupyter, right? And this is because we've grown as people. There's a lot more people involved. There's a lot more projects involved, and it's been 19 years, right? Right. So Jupyter, as Fernando says, is tools for the life cycle of a computational idea. So we're thinking, you're exploring interactively. You're in a terminal, you're in a notebook, you're poking around, you're doing interactive exploration. Then you're building libraries and packages using, standard Python package tooling or whatever language is appropriate. Then you record and collaborate on what you're working with. That's notebooks on GitHub or whatever. You document, demonstrate, and share. You make notebooks, maybe share them with Binder. You create interactive documentation. Or if you're in an academic setting, maybe you're writing a paper and you have a notebook or some other thing for reproducing what you've done. So Jupyter, we have this familiar concept of a notebook with cells and the sequence of cells. There's input, there's output, there's prose. But breaking it down, we have this document format, the notebook document format that's an interchange that we can convert to HTML and share on NBView or on GitHub. But it's also the interactive computing environment, right? It's Jupyter Lab for writing, for executing code, for creating these documents, for that exploration step and that recording process. But it's also the protocol, the low-level protocol on which all of this is built. But also, another thing it is a web application, right? This server application that behind the notebook, the classic notebook application or Jupyter Lab is a web server, and this is a technology stack we happen to choose. But there are important consequences to this that I don't know how many of you recognize a command like this that they maybe did relatively often. So what this command does is let's say I have a computer, maybe my workstation in my office. I say maybe, this is really, I did this all the time in grad school. I have a machine where I want to run code, but I'm at my laptop at home. This says log into the remote machine, forward a port on my laptop to a port on the machine, start IPython notebook on that remote machine, and then I can point my laptop browser at this port on my laptop, and I'll be able to run code in the notebook on the remote machine. So people were building tooling around deploying notebooks online, deploying notebooks on remote resources, whether in the cloud, workstations they have, clusters. People were building a lot of scripts and wrappers around this stuff. And so we have things like IPython Hydra from the Stanford project, where they wanted to give students access to IPython notebooks. So they wrote a PHP application so that everybody who logged in got a notebook server. And because a lot of people were building this kind of thing, we wanted kind of an official solution. We didn't want to expand our scope too much, but we wanted a kind of an official version of, so you've got some computers and you've got some humans who want to use those computers. We built JupyterHub as kind of a simple version of connecting those humans and computers. And so the main thing it did was add this proxy. And so people log in through an authenticator, which abstracted the idea of logging in with something. So deferred to an external service, whether that was your university sign-on or an OAuth provider like GitHub. And then each user would get their own notebook server. And that was another abstract API that we call the spawner, that just is an API that says, I'm giving you a user, please start a notebook server for them, and then when you're done, tell me where it is. And this allowed people to write authenticators with various services and spawners with things like Docker, Kubernetes, or batch systems. In this project, we didn't want to expand our project scope too much, right? It was tightly limited. We only wanted to consider small numbers of semi-trusted users, and we set out from day one to define things as out of scope. Thousands of users. We're not scaling to large numbers. That's not our expertise. You should pay somebody to do that. High availability. This is a deployment concept that we're not building infrastructure for things that that can't be down for a minute while they restart. We also didn't want to deal with running on Windows, right? We were talking about building server infrastructure. This is the kind of thing that's very different on Windows. So we explicitly said, running on Windows is not in scope for this project. So that led to some design decisions that made it enabled us to ship quite fairly quickly. So we can say there's only one hub. There's only ever going to be one hub. It owns a database where it has its state. It does need to be able to restart with minimal disruption, but restarting is okay. These single points of failure are okay because restarting them, they should be able to come back and resume their state quickly, but it's okay if they're down for a little bit. So our first prototype of JupyterHub in 2014, it's 300 lines of code, and there's not a lot to it. You enter your username and the password, and then it spawns something for you, proxies a URL, and you're up and running. So this is the level that JupyterHub was at when we started, got this from Doug Blank, who asked, should this work? And the answer was no, that we were still figuring it out, but because we'd only gotten a prototype of, can we make a proxy do this at all? We were already getting interest in, can I use this to teach my classes? And the other early adopter I want to highlight is Jessica Hamrick, the creator of MB Creator, was so a few months after we got JupyterHub working at all, in January 2015, was deploying JupyterHub in the cloud on something called Docker Swarm. And I really want to emphasize how much of an early adopter this is, because Docker Swarm got its first pre-release a week after Jess was using it, and IPython and JupyterHub got its first release in March, months after these deployments were up and running. So these early adopters really helped us see what was useful, make sure that we were building JupyterHub that was actually useful to people. And importantly, both of these are coming from education, which has been perhaps the biggest source of use cases in JupyterHub. So now it's a much more formidable project, but it's still scoped in terms of code relatively small in Jupyter terms. And if we look at the activity history, this is where Doug and Jess are having their early adoption and showing us what JupyterHub needs to be. But here we can see there's clearly some kind of inflection point where JupyterHub explodes. And so what happened there? Something called Zero-to-JupyterHub. So you don't have time to get into depth on what that is, but it is documentation for how to deploy JupyterHub on Kubernetes that came out of the Berkeley Data Science Education Program, led in particular by UV-Panda. And it's also what's called a Helm chart. So it's documentation and code for deploying JupyterHub on Kubernetes as easily as possible. And it's really phenomenal, both technology and documentation that made it easier than ever to deploy JupyterHub, not just at all, but also in a scalable, cost-effective way. But some keywords from Jupyter in the Kubernetes community are scalability, high availability, and stateless applications. So this is a bit of a not a great fit for JupyterHub that doesn't describe how JupyterHub is built at all. But if we look, if you want to think about, so working well within Kubernetes context is going to involve a change in scope for JupyterHub, right? We're aiming at less than 100 users, right? Tens to 100 users. We can't handle a large number of users. We don't know how to build big scalable applications. We're targeting this use case. But if we look at activity across the JupyterHub organization, so the Zero-to-JupyterHub repo is the pink bit. KubeSpawner is red. That's a big piece of the technology in Zero-to-JupyterHub. And then kind of the main repo is green. And then blue down at the bottom is BinderHub. That's the code that powers mybinder.org, which is also built on Zero-to-JupyterHub. A huge fraction of the activity on JupyterHub in general is devoted to this Kubernetes stack. So we need to think about, if this is what JupyterHub users want, we need to think about how are we strict about the scope of JupyterHub, or do we let it change? So the impediments to scaling and performance in the JupyterHub design, we have these single points of failures. We have these assumptions that prevent us from having multiple hubs talking to the database. And we also have kind of the killer thing for scaling applications is lots of state that only exists in memory, right? Not all of the state of the JupyterHub application is in the database, right? It can rebuild itself from the database, but it doesn't all live in the database. So it can't go from just one request to another and rebuild all its state from the database. This is going to make bringing JupyterHub into this context is actually a really big project that we're thinking about now. The single point of failure issue actually has been addressed. Georgiana has built us this wonderful JupyterHub traffic proxy that can be sharded and have multiple instances, and so that single point of failure is gone. But this in-memory state is still a big challenge for us. And I want to highlight Kubeflow is a machine learning application built on Kubernetes. They wanted notebook servers. They saw Zero-to-JupyterHub as a way to get notebook servers on Kubernetes, so they started using JupyterHub. After a while, the design of JupyterHub and the design of Kubeflow became a challenge, and they started wondering, should we be using JupyterHub at all? And we chimed in and said, you know what? It's actually probably better if you don't use JupyterHub. So we don't want everybody to use JupyterHub just because we made it. It's really important to emphasize that JupyterHub is a way to deploy notebooks. It's never been meant to be the way to deploy notebooks. So if JupyterHub and its design, whether it's the Kubernetes, the Helm chart, or JupyterHub itself, is not a good fit, the answer may not be make JupyterHub a good fit. The answer may be, if you are a deployment expert like the Kubeflow team is, it may be easier for you to write your own deployment tool rather than to reuse something from JupyterHub. And we've done a lot of work over time, especially driven from the Berkeley deployments and the Quantopian deployments to improve scaling and performance of one hub. Right, so we have things where we're finding individual request things that are taking a few milliseconds that we were able to get down to microseconds. We had issues with starting up the JupyterHub with 5,000 user accounts. And just this year, folks have added things like pagination. So things when you've got large numbers of users where it starts to fall down, we've incrementally improved some of those things. But we're still getting questions and issues open, like what works on Windows? Right? We said Windows is explicitly out of scope. You can technically use JupyterHub on Windows thanks to some contributions. Right? We're not going to say, no, you can't even contribute these fixes to the problem. It's not super supported, but people are using it and they're contributing the fixes they need. And so we're doing that. We have support high availability, right? We have a description of why we can't do that, why we don't do that on purpose, but it's an area of active interest, so we're reconsidering, what we should do about it. And in this project scoped at a few hundred users, we have issues like there are problems when we've got 50,000 users. And the answer isn't you shouldn't do that. There's an ongoing conversation. And there are things we can solve. We can incrementally solve these problems to, remove roadblocks. But there's increasing pressure on the project to say, maybe we need to think about new architecture with availability and scaling, and that's something that we're thinking a lot about. But just highlighting, when is it time to expand the scope of a project, right? You want to meet users where they are. We built JupyterHub for a use case. Turns out people want to use it for a different use case, and that's okay, right? It gives us work to do, but we're solving real problems, right? We did the easy thing first, but now we're slowly biting off harder and harder problems to solve, so that people who want to use it can. And sometimes redefining the scope of the project is the right thing to do. And the most important thing is getting more people into a maintenance role, right? The JupyterHub team is a lot of wonderful people. It's not just a couple, and that really helps spread the load. So it's really important to bring people into the team and give people authority to help steer the project and respond to the folks who want to use it and make it actually useful to people in the world. And that's what I have to say this morning. Have a wonderful rest of the day, JupyterCon, rest of the week. Thank you.
Thank you very much, Min. I was just wondering how one goes about clapping at the end of a keynote in this format. And that's one thing we've lost the capacity to clap for your presentation. Yes. Sylvain, do you have any questions from the audience that you want to share?
Yeah, there's a certain Zach Sater wants to know if you were falling behind in your undergraduate classes during your time working on IPython.
It was, I didn't need as much sleep as an undergraduate as I do now. Yeah, it was a lot. Yeah, it was it was a lot of work. But it was, yeah, definitely some classes probably suffered. I think probably my PhD suffered more than when I was an undergraduate. I think IPython Jupyter definitely probably cost me a year in my PhD, but it was worth it because it's been my job ever since.
Okay, I have a question. How do you keep a balance as an open source maintainer between being the gatekeeper for scope, screaming out of scope to the wind, and the fun of cutting corners and hacking a prototype for the next moonshot feature? Like, where's the fun in being the gatekeeper?
So being a gatekeeper is not fun. I think how you maintain that balance by, I think that's one of the hardest things as an open source maintainer, is managing that balance. And how you giving yourself time. So one of the hard things about those of us for whom this is our job is that contributing things for fun is a lot less fun. But trying to carve out some of that time to say, like, I'm going to do some work that not because it's the important thing for the project, but I want to spend this block of time on doing just what I think is fun to do, can really help maintain kind of enthusiasm and the ability to stay with the project.
Thanks. We have a question on Mattermost. How many users is too many for JupyterHub deployment, and when is it time to switch to traffic?
Switch to traffic as soon as we can get the Helm chart updated. So we've actually done, I would say, 1,000. So if you're working really hard and optimizing and paying a lot of attention, you can get a few thousand concurrently active users in JupyterHub with Kubernetes. I would say it's more comfortable under 1,000. And if you're expecting to routinely be over 1,000, you should start looking into kind of multi-hub deployments like UV and the Berkeley folks did, and the Quantopian deployment. And that's something we've talked about. This kind of sharded multi-hub. Should we bring something like that into the JupyterHub organization as kind of an official, right? We've got a kernel and then a notebook, and then a hub deploys multiple notebooks, and then this deploys multiple hubs, and just keep stacking it all the way up. And it's possible that is something that belongs in the JupyterHub org. But I would say about 1,000 is what one hub can reasonably handle, and that's not total users. That's active, like currently logged in and running. It's people are running into issues with, as I said, 50,000 users, just existing users. So less than that.
Thanks, Corinne. Do you have any other question that you could catch?
Yeah, there's another question in the Q&A. The question says, I saw a comment on Twitter that R Markdown allows users to run one line of code at a time, which is not doable in Jupyter. Is this true? If yes, is this functionality on the roadmap for Jupyter?
So I would say that's kind of a UI question. There's no technical limitation to that. It is it's a simple matter of user interface implementation, which is one of the hardest things we have. But in terms of the protocol and everything, stepping through some lines of code, there should be no problem with that. Well, as long as they're, I guess, blocks of code would be. Individual lines might actually be a challenge, but blocks of code should be fine. There are technical issues with Python that would make actual individual lines a challenge because it's not syntactically complete, one line at a time.
The other question we have there is, will a multi-kernel feature of a notebook be in your scope?
So is a polyglot notebook something that we plan to do in Jupyter? There aren't plans to do it. I actually wrote a kernel called All the Kernels that where from the notebook perspective, the kernel is it's a kernel implementing the kernel protocol, but from the implementation of the kernel is actually it's a client talking to other kernels. So it's like every cell is a cell magic talking to another kernel. And part of the reason I did that was to demonstrate that Jupyter doesn't really need to know, right? Jupyter knows that it has a kernel, and then it's up to the kernel to decide what execution means, and that could mean that this cell's in one language, this cell's in another language. So you can build a polyglot notebook by building a polyglot kernel. Mine was kind of a toy, but other folks have built, like the Calico, I think, have built more actually useful ones. There are things we could do at the Jupyter level. There's not a technical, it's again, that's a UI question. And so we've chosen not to implement that. But there's not a technical reason why we couldn't have a document. We couldn't build a web application where you have a document and you hooked up each cell to a different kernel, because each cell is actually independently hooked up to the kernel. It's more a question of how you express that UI. And there have been polyglot notebooks like Beaker that actually also have a data interchange layer. So you can have variables that exist in multiple languages that are serialized and shared across each other. That kind of thing is, again, something that could be implemented at the kernel level so that we don't have plans to do in Jupyter anywhere.
And there seems to be another question in the Mattermost chat. It says, according to you, Min, what's the next big thing in the Jupyter ecosystem?
In the whole Jupyter ecosystem, what's the next big thing?
Yes.
Well, can I say Jupyter? It's not so much in the future anymore because it's now, but extremely recent is Jupyter Lab installing extensions without rebuilding is it's at least going to make my life way better. So that's pretty big to me.
And someone just posted a new question. Is there a roadmap integrating Voila into JupyterHub?
So there isn't a roadmap for that, but the biggest piece was supporting the Jupyter server. So, right, the Jupyter Notebook has been forked into this standalone Jupyter server, and that's what Voila is based on. And that code has landed in JupyterHub as of last month, I think, and so should be released as soon as I can stop working on my keynote and start working on helping the JupyterHub team ship the release. Then that should actually be the biggest piece missing for Voila integration with JupyterHub. So look for that next week.
Great, and let's, I think, wrap up. We're 5 minutes after, but it's I think there's a break coming up in the program now. And Min, we can invite you to go back and check on the Mattermost and interact with the other participants who might have questions, right? All right, can you take over, Sylvain, to close and stop the recording?
Sure. Thanks, everyone. Many thanks to Min. Enjoy JupyterCon.
See you.
See you.
Bye.